Hello friends, welcome back. Hearty welcome to you. Let us look at this problem. Determine a comma b and c so that f of x is defined for different intervals. One x less than 0, another x equal to 0, another x greater than 0 is continuous at x equal to 0. Now when they gave the definition of function, we have some constants there, a in the left hand side and b in the right hand side, and when x equal to 0 we know it's equal to c. So we have to find out the values of a, b, c if we know that this function is continuous at x equal to 0. Now actually what's the meaning of the function is continuous at a particular point? Let's write down that first. What we know is, if a function is continuous at a particular point, then we know that limit of x, let us say the point is a, x tends to a minus, that is left hand side, f of x should be equal to limit x tends to a plus, that means right hand limit for the function should be equal to value of function at that particular point, that is nothing but equal to f of a. If this satisfies, then we can say that the function is continuous, because we have limit. What is the meaning of limit x tends to a minus f of x equals to limit x tends to a plus f of x? The meaning of that is that limit exists at that particular point a and it is equal to, that is the meaning of 1 and 2. F of a means the function value at x equal to a. If all the three are equal, then only the function will be continuous. Otherwise the function is not continuous at that particular point. Now let us look at the definitions we have been given. Limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 0. So when x is less than 0, the definition of function is given by sine of a plus 1 into x plus sine x by x. When x is greater than 0, the definition is given by square root of x plus b x square minus root x by b into x power 3 by 2. And when x equal to 0, it is equal to c. So all these three conditions should give the same value. So we leverage that. From that we should be able to find out the values of a, c and b. So first we will start with the left hand limit. So let me write down that for left hand limit. For left hand limit, what we will say? We will say that x equals to 0 minus h such that as x tends to 0, h also tends to 0. X equals to 0 minus h, because x tends to 0 minus means we are coming from a value which is less than 0 towards 0. That is the meaning of 0 minus. So let's substitute what is our function then. We will write down f of x is given by sine of a plus 1 into x, x is 0 minus h, plus sine of x, that is again 0 minus h, divided by x, which is equal to minus h. Now let's do the left hand limit for that. So we'll say limit x tends to 0 minus, or we can also write down h tends to 0, f of x will be sine of a plus 1 into minus h plus sine of minus h divided by minus h. We simplify that. What we will have? We will have sine of a plus 1 into minus h by minus h. So we'll write it in the next step. That is equal to, can I write it as sine of a plus 1 minus of a plus 1 into h divided by instead of minus h, I should have a plus 1 into h. I have to multiply with a plus 1. As h tends to 0, a plus 1 into h also tends to 0. This then minus sin h divided by minus h, nothing but plus h. This is as h tends to 0. We have a limit here. We have a limit here. So now what this became? This became, now this whole thing will become 1 and this will become 1. So our next step will be, which is equal to a plus 1 plus 1, which is equal to a plus 2. So a plus 2 is what we got from left hand limit. So let's write down that what we have done. We have taken sine of a plus 1 x plus sine x by x. We are x less than 0, so we x equals to 0 minus h. As x tends to 0, h tends to 0. We simplify that, we got a plus 2. Now let's go to the right hand side. We will write down, as x tends to 0 plus, let us say let x equal to 0 plus h, in such a way that as x tends to 0, h also will tend to 0. Now what is x tends to 0 plus? That means we are coming to 0 from 0.1 or 0.01 to 0. So it is more than 0 value coming towards 0, or it is also known as right hand limit. So we have right hand limit here, we have left hand limit. So now let's substitute and see what will happen. What is our right hand limit? That will become limit h tends to 0. If x is greater than 0, then the function is given by root of x plus bx square. So can I write down, x is 0 plus h, so can I say h b into x square, that is bh square minus root of h divided by b into x is 0 plus h, that is h only, h power 3 by 2. So as h tends to 0, root of h plus bh square minus root h by b into h power 3 by 2, because x is 0 plus, so we have taken 0 plus h in such a way that if x tends to 0, then h will tends to 0. Now let's substitute here h equal to 0. We are getting 0 by 0 form. Since we are getting 0 by 0 form, but we know that the limit should exist here because we have been given that the function is continuous. So what we will do, we will apply L'Hospital's rule and we will try to differentiate both numerator and denominator. Before that, we will take something common. We will take root h common in the numerator. So it will become root of 1 plus bh minus 1, that is root of 1 plus bh minus 1 divided by b into h. Now we will write down limit h tends to 0. This is also equal to, now 1 root h will cancel. We are left out with root of 1 plus bh minus 1. We can do the derivative of that, divided by bh derivative. So what is derivative of root of 1 plus bh minus 1? That is 1 by 2 root 1 plus bh, 1 by 2 root 1 plus bh, and bh we will have chain rule, say b, divided by denominator bh derivative is b only, and b will cancel. We are left out with 1 by 2 root 1 plus bh, and this is limit. Everywhere we have to write limit h tends to 0, again limit h tends to 0. Now substitute h equal to 0 there, you will get value equal to 1 by 2. That means right hand limit is equal to 1 by 2. So what we have done, let me just recap this, because this particular part is not covered in lot of textbooks, at least in NCERT. So let's understand this. Whenever you have a function for which the limit limit is in the form of 0 by 0 or infinity by infinity, indeterminate form. According to L'Hospital's rule, what we can do, we can differentiate the numerator and denominator till we get a value. So we did differentiate here and we substituted h equal to 0, we got 1 by 2. So then we know that right hand limit equal to 1 by 2, and we know function value is equal to c. So a plus 2 equal to 1 by 2 equal to c. So let's write down that. So left hand limit is a plus 2, right hand limit is 1 by 2, and the function value is c. All of them should be equal, then only the function will be continuous. So from that we know c equal to 1 by 2 and a equal to 1 by 2 minus 2, which is equal to minus 3 by 2. And what about b value? When we did right hand limit, we understood that b is cancelling it out. That means whatever may be the value of b, b will take any value throughout real numbers. So can we say b any value from r? So a equal to minus 3 by 2, b can be any value, and c is equal to 1 by 2. Now what is difference in this particular problem when compared to the regular problems is, this second part we are unable to do the limit by just applying the general whatever we know, either factorization, rationalization, none of the formulas are working out. Then we know it is in 0 by 0 form still. After you do everything, then you have to go for L'Hospital's rule, and we differentiate numerator and denominator and substitute the value of limit. Here h tends to 0, so put h equals to 0. We got the answer equal to 1 by 2. As continuous, the function is continuous, certainly right hand limit should exist. That means it cannot be 0 by 0 form, so we have to find out its value, and its value is equal to 1 by 2. Left hand limit gave us a plus 2, right hand limit gave us 1 by 2, and we know the function value at x equal to 0 is c. So if the function is continuous at x equal to 0, then left hand limit should be equal to right hand limit should be equal to the function value. That means simplifying, a equal to minus 3 by 2, c equal to 1 by 2. b can be any value, because when we did right hand limit, we observed that b gets cancelled out. So it's irrespective of whatever the value b have, always the right hand limit will be equal to 1 by 2. So b can take any value. So b belongs to r, or b can be any value from real numbers. So that's one interesting example I just thought of sharing with you. Please do let me know your feedback. Thanks for your time and support. Bye for now.